Good day all. This is Limpid Scholars tutorial and my name is Goodness. We'll be solving chemistry 2021 UI post UTME questions. So we're going over to number 1. The oxidation state of S in Ca bracket HSO3 bracket 2 is. So we'll be solving this is so number 1. Oxidation state, remember, when when it doesn't have a charge, it is equal to 0. Like a neutral compound, when it doesn't have a charge, is equal to 0. So we solve Ca bracket HSO3 bracket 2 is equals to 0. So you know that oxidation number of calcium is +2. For our hydrogen is 1 times 2, plus we're looking for the 2 times S is 2S, plus bracket minus 2 times 3 times 2 is equal to 0. So what next? Plus 2 bracket 1 times 2 is 2, plus 2S, plus 3 times 2 is 6, and 6 times 2 is -12. -12 is equals to 0. Plus 2 bracket 2 plus 2S plus minus is -12 is equals to 0. So plus 2 plus 2 plus 2S minus 12 is equals to 0. 2 plus 2 is 4 plus 2S minus 12 is equals to 0. Taking both this, yes, taking both this one and this one to this side will give us plus 2S is equals to 12 minus 4. Then using my calculator, 12 minus 4 is 8. So plus 2S is equals to 8. Dividing both sides by 2, S is automatically 4. So our answer for this is plus 4. We're going over to number 2. We're done with this one. So we're going over to here. The oxidation state of P in H2P2O7 raised to power 2 minus is. Okay. Number 2, we have H2P2O7 2 minus. Remember, since it has a charge, 2 minus, it will be equal to not 0 now, but it will be equal to -2. So we have H2P2O7 equals to -2. Remember, we're looking for the oxidation state of P here. So 1 times 2 plus 2P plus, remember, the oxidation state of oxygen is -2 plus -2 times 7 is equals to -2. 1 times 2 is 2 plus 2P plus 7 times 2 is 14 plus minus is -14 is equals to -2. So we'll be taking this and this over here. So plus 2P is equals to 14 minus 2 minus 2 plus 2P is equals to 14 minus 2 is 12, and 12 minus 2 is 10. So dividing both sides by plus 2, P is automatically 5. Then we're going over to number 3. Okay, sorry, let me think. The answer here is 4. So we're going over to number 3. Potassium ethanoate is formed when A. Methanoic acid reacts with KOH. B. Ethanoic acid with KOH. C. Methanol with K2CO3. D. Ethanol with CH3COH. So now the answer is ethanol or ethanoic acid with KOH. Remember here, we're seeing X and we're seeing potassium. So now, for us to have this product, we're looking for the two reactants. We're looking for the two reactants that gave this potassium ethanoate. So whatever we're looking for must have X, which this one has, and must have potassium, which is also here. So we're going to write the equation of reaction, which is ethanoic acid. That is number 3. We have CH3COOH plus KOH will give us CH3 COOK plus H2O. I would like to chip this in that this is not esterification reaction. Instead, it's a neutralization reaction. Remember, esterification reaction is a reaction between an alkanol and an alkanoic acid to yield an ester and water. But this reaction, it's a neutralization reaction using an acid and a base to form a salt and water only. I think that's clear. So we'll be moving over to number 4. Number 4, yes. Calculate the mass of oxygen produced when 3 grams of KClO3 decomposes according to the equation 3 KClO3 to 3 KCl plus 3 O2. So number 4, number 4. They've already given us the equation of the reaction, so we'll be looking for the molar mass of this. So firstly, molar mass of KClO3. Remember, our K is 39 plus 35.5 plus oxygen is 16 times 3. So our final answer for the molar mass of KClO3, 35.5 plus 16 times 3, will be getting 122.5 gram per mole. And remember, for the oxygen, which is O2, is automatically 32 gram per mole. You get? So remember, what we're looking for is the mass of oxygen produced. So we are comparing KClO3 to oxygen. So remember, in this reaction, we can see that 3 moles of KClO3 yielded 3 moles of oxygen. And remember the molar mass of this KClO3 is what? 122.5 yielded what? 32. So how many X? Yes, we're looking for, calculate the mass of oxygen. Yes, we're calculating the mass of oxygen. So this, I think I made a mistake here. Yeah, so this 32 here. So we are looking for 3 grams. We already have 3 grams of it. So what will it give us here? We'll cross and multiply. So 32 times 3 is equals to 122.5 X. Dividing both sides by 122.5. 122.5. So we have 32 times 3 divided by 122.5. We are having, which is equals to 0.78 grams. That's the answer. So we'll be moving over to number 5. Number 5. The compound used in weathering of mortar is. So now I would like to chip this in. Weathering of mortar refers to the breaking down of mortar due to exposure to natural and environmental factors. Mortar is a mixture of sand and lime. So I'll be writing the equation of the reaction. Before that, mortar, let me just chip this in also. Mortar hardens when it absorbs water and its reaction with carbon dioxide. Therefore, the compound used in weathering of mortar is automatically calcium hydroxide. So this is the equation of the reaction. Calcium hydroxide plus CO2 giving us CaCO3 plus H2O. We'll be going over to number 6. 0.6, this is number 6. 0.6 gram of methane when burnt increases the temperature of 100 gram of, I think this page is not complete. Okay, let me just write out what we have. Let me change my page. Come in. Yes. So 0.6 gram mass of methane to be what? 0.16 gram. When burnt, increases the temperature of 100 gram of, let's know what's next. 100 gram of water. So 100 mass of water equals to 100 gram by 40 degrees Celsius temperature. 40 degrees Celsius. 40 degrees Celsius. What is the heat of combustion of methane? If the heat capacity of water, we have given us heat capacity. Sorry for that noise. Heat capacity to be 4.2 joule per gram. Yes, so firstly, we'll be finding our heat, the heat energy absorbed by water. The heat energy absorbed by water, which is our Q, equals to MC change in theta. Our M is for, remember, this heat absorbed by water is 100 gram, that is the mass, times the specific heat capacity, which is 4.2 gram, times temperature change, which is 40, which will give us what? 100 times 4.2 times 40 will give us 16,800 joules. So now, next, what we are going to be looking for, we have to change this mass of methane. This mass, we have to change it to what? Moles. Because remember, what we are looking for is the heat of combustion per mole. Based on the question, if you see, look at it, heat of combustion per mole. We're looking for the heat of combustion per mole. So we have to change this 0.16 gram to mole. And remember, mole is equals to mass over molar mass. Then mole is equals to what's our mass? 0.16 gram. I think that gram is not needed. Over our molar mass, look at it here. Our molar mass, CH4, is equals to what? 16. So dividing 0.16 divided by 16 is what? 0.01 mole. So now we're looking for the heat of combustion per mole of methane. So what we are going to now do is dividing this heat energy absorbed by water, dividing it with this. So let's go. This heat energy absorbed by water, I'll do it like this: 16,800 divided by 0.01. Remember, what we are looking for is nothing but the heat of combustion. We're looking for the heat of combustion. So now dividing it, 16,800 divided by 0.01, we are having 16,800 divided by 0.01, we're having 1680 kilojoule per mole, making this the correct answer. So we'll be going over to number 7. Another name for heavy water is number 7. Another name for heavy water is called deuterium. Deuterium, this is the symbol, that is number 7. Deuterium is the symbol. Sometimes people, you can write like this, but another thing is like this also. This is what? Deuterium. And it is heavier because it contains extra neutron. It is heavier than protium because it contains extra neutron, and it is used in nuclear reactors as a moderator. It is used as a moderator in nuclear reactors. So we'll be going over to number 8. Uses of chlorine in water purification. Chlorine is used to kill germs. Chlorine is used to kill germs in water purification. And then we go over to number 9. The particle with the highest penetrating power. Okay, I think I forgot to tick my answers. Okay, we're done with this. The particle with the highest penetrating power is what? Is gamma ray. Gamma ray has the highest penetrating power. It can pass through paper, through aluminium, but it stops with thick lead sheets. Gamma ray is caused by thick lead sheets. It is an electromagnetic wave. It is used to heal cancer. It has no charge and mass, and it is used in the treatment of cancer. We're going over to number 10. Alkaline pyrogalol increases in weight when it absorbs A, nitrogen, B, oxygen, C, CO2, D, rare gases. The answer is oxygen. Alkaline pyrogalol, also known as benzene 1,2,3-triol, absorbs oxygen from the air because of its alkalinity. It absorbs oxygen. Like when during if you want to separate oxygen, like you want to remove nitrogen from the air, you can use alkaline pyrogalol to remove oxygen, and then with other means you can remove other rare gases and CO2. So thank you for watching. I need you to like, subscribe, and share this video. Promote this channel.